Okay. So we discussed this, we discussed the expressions to find the mole expression. Find the mole fraction, mole pressure, mole fraction, partial pressure. How can we find these? Now, before heading towards the past paper question related to Keyboard, I just want to discuss the factors affecting. This is the reason that sometimes examiner asks you Kc value and Kp value. So we are going to discuss these factors. Okay. So you have to remember this thing that pressure and concentration change does not affect either Kc or Kp value. So if we change the pressure or if we change the constant, okay, pressure does not affect Kc because pressure, Kc, and concentration as well, these two things does not affect Kc or Kp value if we increase or decrease. Okay. Basically, Kc or Kp are the temperature specific constant. It means that at a specific temperature, their values remain same, but when the temperature changes, the Kc and Kp value changes. Yes, subjoined here. So you guys have to remember that only changing temperature affects the Kc and Kp value. So it means when we change the temperature, there will be a change in Kc and Kp value, which is observed. But when we change the pressure or we change the concentration, there would be no change in Kc and Kp value. They stays constant. Is this clear to all of you?
Yes, sir.
Now, so temperature, if you remember temperature, when we change the temperature, it affects the endothermic or exothermic reaction. So when we increase the temperature, endothermic reaction occurs, equilibrium shifts towards the endothermic side, and when we decrease the temperature, exothermic reaction occurs, equilibrium shifts towards the exothermic side. Okay. So in endothermic reaction, if temperature is increased, so endothermic means forward reaction will be endothermic or backward reaction will be endothermic. Yes. If the reaction is endothermic, then forward reaction will be the endothermic or backward reaction will be the endothermic.
The forward.
Forward. So if the forward reaction is endothermic and if I increase the temperature where the equilibrium shifts towards and right or towards left,
Left.
why? Yes, when we increase the temperature where the equilibrium shift towards endothermic or exothermic. Yes, why you guys are blank? I don't understand.
Sir, exothermic?
Don't just guess. Look, if you don't remember, just look over here. We have discussed earlier in this chapter. See over here. If the forward reaction is endothermic, then equilibrium shifts towards the right. And if equilibrium shifts towards the right, then what will happen to the product? Will product form in a greater amount or in a lesser amount? Yes. So if we increase the temperature, equilibrium shifts to right. And if equilibrium shifts to right, then what happens to the amount of product? Will it increase or decrease? Yes, please.
It will increase.
It will increase.
Increase.
And the reactant will decrease. So if you recall the Kc or Kp expression, both the Kc or Kp expression, the products are in the numerator and the reactants are in the denominator. So if the numerator are increasing, then Kc and Kp value increase. So what will happen? Next, that Kc or Kp value increases. And for an endothermic reaction, if I lower the temperature, then obviously on lowering the temperature, equilibrium shift towards the exothermic side. So it's endothermic, which means that the forward reaction is endothermic. And if the forward reaction is endothermic, then it means the backward reaction would be exothermic. So equilibrium shifts to the left, backward reaction occur, and as a result, the amount of products decrease and the amount of reactant increases. And in Kc or Kp expression, the reactants are in denominator. So when the denominator value increases, then Kc Kp value decreases. Is this clear to all of you?
जी sir.
Yes,
Yes,
Hamza
sir.
and Ashal, is this clear?
Yes, sir.
Yes, sir. Yes.
You guys are not remembering the things. You are not reviewing the concepts. So for an exothermic reaction, it means that it is for forward reaction, that forward reaction is exothermic, and if forward reaction is exothermic, then backward reaction would be endothermic. So if I increase the temperature, equilibrium shifts towards the endothermic side, and in this case, the backward reaction is endothermic. So equilibrium shifts to left. So as equilibrium shifts to left, more reactant will form and the product decreases, and product in the numerator and the reactants are in the denominator. So as a result, Kc or Kp value decreases in this case. Is this understandable to all of you?
Yes,
Yes.
sir.
जी.
Okay. So. No, you are not audible, Ashal. If we decrease the temperature, equilibrium shifts to right because forward reaction is exothermic. And if equilibrium shifts to right, more product will form and product is in the numerator. So hence Kc or Kp value increases. Yes, is this clear to all of you?
Yes, sir.
Okay.
No, Ashal, I didn't able to hear you.
Sir, am I audible now?
Yes, now you are audible, but your voice is very low.
Okay, sir, let me fix that.
Okay. Now, now we are going to attempt a question. This is the whole question that we are going to attempt today. And then I will give you one question for you guys to attempt it, okay? Now, let's start. Now, if I ask you guys, please do respond. Nitrogen dioxide exists in equilibrium with a dinitrogen tetraoxide N2O4. And here is this equilibrium equation over here. Now, 2 moles of dinitrogen tetraoxide was sealed in a container at 350 Kelvin. After equilibrium had been established, the total pressure was 150 kilopascal. So it means they have given you the total pressure over here. Is this understandable to all of you?
Yes, sir.
Yes, sir.
What about these 2 moles? Are these initial moles or at the moles at the equilibrium?
Initial mode, sir.
Initial moles.
Initial moles. And the mixture of gases contain 1.84 moles of dinitrogen tetraoxide after equilibrium had been established. So it means these 1.84 moles are at equilibrium or initial.
Equilibrium, sir.
At equilibrium. Is this understandable to all of you?
Yes,
Yes,
sir.
sir.
Okay. Now they are asking give the expression for the equilibrium constant Kp for this equilibrium. So if I will write the Kp expression, if you guys recall, we have discussed that it is the partial pressure of the product. There is 1 mole of the product, so we will not put any power, right? Divided by partial pressure of the reactant raised to the power, which is the coefficient in their balanced equation. So it has a coefficient square. There are 2 moles. I will put a power a 2. Is this clear to all of you? Yes, is
Yes,
this?
sir.
Yes.
Now what they are asking, calculate the number of moles of NO2 present at equilibrium. Yes, so can anyone tell me how we will find the moles at equilibrium? What I have told you to do when you have to find the moles at equilibrium.
Sir,
using
through
the
ice table.
table.
Sorry?
Through
Using
ice
the
table.
Yes, very good. Through ice table. So let me write the equation over here. 2 moles of NO2 and 1 mole of NO2O4, and for ice table I'll make 3 rows, one for I, second for C, and third for E. That is initial change and equilibrium. Is this clear?
Yes, sir.
Okay. Now, what are the initial moles?
Sir, 2.00.
2.0, and of which substance? Dinitrogen tetraoxide or nitrogen dioxide? Is it a reactant or a product?
So reactant.
Product.
Product.
It's a product, right?
Yes, sir.
So 2.00 initial moles. Then at equilibrium, the 1.84 moles are of the reactant or the product?
Product.
Product. So I will write over here 1.84. Is this understandable to all of you?
Yes, sir.
Yes,
Now
sir.
now what is the change?
0.16.
Is it negative or a positive change?
Positive.
Why? See, initial moles are 2 and the final moles at equilibrium, the moles are decreased. So the amount is decreased or increased?
Decreased.
Okay, sir.
Decreased.
Negative.
So it means that this change is negative. So it is 0.16. Is this understandable to all of you?
Yes, sir.
Now tell me
Yes, sir.
what were the initial moles of NO2? Did they take the initially the amount of NO2 in the container? Yes.
No, sir.
So the initial moles of NO2 would be 0.00. Is this clear?
Yes, sir.
Yes, Hamza and Yusuf.
Yes, sir.
Yes, sir.
Now, if you take the ratio of the product with the reactant, then what is the ratio? Product is to reactant. What is the ratio?
Sir, 1:2.
2:1.
1:2. So if 1 mole of product is consumed, then 2 moles of reactant would form. So if 0.16 moles of product would consume, then how much moles of reactant would form?
0.32.
Sir, 0.32.
0.32, twice of my 0.16, and it would be a positive because the reaction is taking place in the backward direction. So it is twice of 0.16, so which means 0.32. So at equilibrium, we got the moles of NO2 and which are 0.32. So I will write over here moles of NO2 at equilibrium 0.32. Is this understandable to all of you?
Yes,
Yes,
sir.
If anyone of you has any confusion, please ask.
no, sir, it's clear.
Okay. Now what they are saying, calculate the total number of moles of gases present at equilibrium and hence the mole fraction of each gas present at equilibrium. So if I go for the total moles, then the expression would be total moles is equals to moles of NO2 plus moles of N2O4. So the moles of NO2, just give me a minute. So moles of NO2 are 0.32 and moles of N2O4 are 1.84. So if you add them, what moles you will get? 2.16. Yes. Are we getting 2.16 the total moles? Is this clear?
Yes, sir.
Okay.
Yes, sir.
Now, Hamza, can you tell me how I will find the mole fraction of NO2?
How to find what? Mole
Mole
fraction.
fraction of the nitrogen dioxide, NO2.
Um, no, sir, I'm not getting it.
Why? You were present in the last class. Yes, Ashil, can you tell me how we will find the mole fraction of NO2? Just check the previous lecture if you don't getting it.
Sir, by dividing them.
By dividing which things, which values?
Sir, the net total divided by the of that N2O4.
What was the mole fraction formula of a mole fraction? If I have to find the mole fraction of NO2, then what is the formula? Yes, Hamza and Ashal.
Sir, I think I wasn't in the last class, so I don't remember.
Yes, Hamza. Kubra, can you tell me the formula for a mole fraction?
Sir, moles of NO2 divided
Moles of NO2 divided by total moles. So the moles of NO2 at equilibrium are 0.32. Total moles we found is 2.16. And in the same way, if I will find the if I need to find the mole fraction of N2O4, I will divide the moles of N2O4 by total moles. So 1.84 divided by 2.16. Yes. Answer please.
Sir, the first one is 0.148.
First one is
148.
0.148 and it's a mole fraction. So fraction has no units. And the second one,
Sir, it's 0.851.
for the mole fraction of N2O4, can you repeat?
Sir, it's 0.8518.
0.8518. So I will write 0.852.
Yes, sir.
Is this understandable to all of you?
Yes, sir.
Yes, sir.
Okay. Now we got the mole fractions. Now see what they are asking. Calculate the partial pressure of each gas present at equilibrium. So the partial pressure formula was, if I have to find the partial pressure of NO2, then it is equals to mole fraction of NO2 multiplied by total pressure. And if I have to find the mole fraction of, partial pressure of N2O4, then it is equals to mole fraction of N2O4 times total pressure. So in the start of the question, they have provided us the total pressure, which is 140, and we have just found the mole fractions of both. So the mole fraction of NO2 is 0.148 times total pressure, PT. Total pressure is 140 kilopascals, right? So 140, and the mole fractions of N2O4 is 0.852 times 140. Is this clear to all of you?
Yes, sir.
Now please tell me the values.
Sir, the first one is 20.72.
20.72.
Yes, sir.
And the second one?
Sir, 119.28.
119 or 190?
Sir, 119, 19.
119.28.
28.
Is this understandable?
Yes, sir.
Okay. Now we got the mole partial pressures. Now what they are saying in the next part, calculate the value of the equilibrium constant Kp at 350 Kelvin. Give your answers to three significant figures and include units. Okay, so we have a kilopascal as a unit of a pressure, and we have this expression for Kp, right? So partial pressure of N2O4 times oh sorry, divided by square of the partial pressure of NO2. So if I calculate the Kp expression, it is equals to N2O4 119.28 divided by 20.72 square, because it has a square in the Kp expression. Now you will solve it and you will get the answer. It's 0.2778.
Yes, sir.
Okay, and see, you have to write in three significant figures, so it would be 0.278. So you will write 0.278. Now you have to find the unit. So the unit is kilopascals. So kilopascals in the numerator and kilopascal square in the denominator. So it would cancel out, and we are left with kilopascal inverse square. So it would be kPa inverse square. That is the unit. Is this clear to all of you?
Yes, sir.
Yes, sir.
Okay. Now, there is a one question for you guys to attempt. Here you go. Read the question carefully, attempt it, and send me all the working along with the answer. I just don't want only answer. I want all the working. Okay. Start doing it quickly.